Hi, Kevin. Can you hear me?
Hello.
Hi, Kevin. Can you hear me now?
Yeah, I'm just gonna choose my virtual background.
Yeah. We seems to have 7 people waiting already, so I think it should be okay.
No problem. And IoT. Virtual background. No. So, do you want me to share screen and try it?
Yeah, I can stop my screen share. Give it a go. You're a co-host.
Okay. Okay. You can
Yeah,
see the screen.
that's great.
Do you want me to turn off screen share first and then go into screen share, or do you want to just leave it like this?
Maybe we have that title thing up that we had, and
First,
then
yeah.
I introduce you, and then you take
Yeah, and then
over.
I'll just do screen share.
Yeah. So let me just get back to my screen share now. Mike Hooligan is there as well, so admit Mike.
Is Mike there? Yeah.
Yeah, he's there. I'm just going to Mike is co-host now, and I am going to unmute, or maybe he's on he'll be unmute anyway. Ask to unmute.
Hey Kevin, can you hear me?
Hey Mike, how are you?
Very good.
Hi Mike.
Hey Fazim, how are you doing?
Good. How are you?
Very good, thank you.
Kevin, can you just try to mute and unmute yourself there now? I'm just making sure like you don't need my permissions anymore to mute unmute, yeah? Oh no, you are on mute.
Okay.
Yeah. You have the full control of your mute and unmute now.
Yeah, I have. So my video is on. You can hear me clearly, can't you?
Yeah, that's all good now. And
so
Mike,
the nod at whatever 20 or 12:15. I'll do a screen share. I'll go first for 20 minutes. If I'm going over 20 minutes, make sure to cut us off. And then I'll hand it over to Mike. Mike is based there out in Pennsylvania, so we've been working with Mike for the past few months, Faizan. So Mike will then take over, and then I've sent you a few kind of sample questions. So if it's a bit silent, hopefully not. You threw off a few of those questions at us, okay?
Yeah, that's fine. I think we're good in numbers. Like the other rooms didn't have too many people anyway, so I'm assuming that it's going to be good anyway.
Okay, we'll talk.
Just a quick one, guys. I couldn't do the background. I'm running on a Mac, and when I went into Zoom and set up an account last night, it wouldn't allow me to use that background. It said that the iOS doesn't support it.
That's okay, Mike. It was just the background still looks okay to us. Like
one minor one. I did, and I had put together an email last night just to send to you. I literally just saw that it was still in my inbox or my outbox. I hadn't sent it. Just the photograph in the social media thing, that was a different Mike Horrigan, but it's a minor point. I put a photograph in my presentation anyway. Kevin knows what I look like.
Yeah, he's usually shy face and he always has the camera off.
Yeah. We're doing well here now.
So we're going live then in 1 minute. I'll just admit the guys who are in the waiting room then, and off we start. 7 participants. Yeah. Hello and welcome to the Beyond IoT 4.0 workshop 3.2. I am Fazan from Nimbus Research Center at MTU, and I'll be moderating this session. The title of this workshop is Extended Reality, Future of AR/VR, and will be presented by Mr. Mike Corrigan from Horizons Control Group and Mr. Kevin O'Mahony from Nimbus Research Center. Mike is the founder and owner of Horizons Control Group, and his active expertise spans a broad spectrum of services in the digital process automation arena, including front-end studies, capital cost estimating, project management, digital transformation consulting, and automation training. Mike also established the International Academy of Automation Engineering and also acts as a board member for a technology organization and nonprofits. Our second speaker, Kevin, is a research fellow at Nimbus Research Center, and his core expertise lie in the areas of UX, UI design, with a particular interest in designing innovative interactive solutions for education and healthcare domains. And now Kevin has also supported multiple startup companies and SMEs through Enterprise Ireland funding and industry partnership programs, where he has delivered 40 Enterprise Ireland and EU funded projects. Now, the format of the workshop will be a presentation from the speakers, followed by a Q&A sessions. And so I would like to request all the participants to take part, by typing your questions into the chat area. And towards the end, I will ask the speakers to, address those questions, and please note that this workshop will be recorded. Now I'm pleased to welcome my first speaker today, and I'll hand it over to Kevin to begin the workshop. Kevin?
Thanks, Faizan. I'm just going to do a screen share there.
Yeah, I'll just stop sharing my screen and then you can take over.
Right, thank you. So you can see my screen, yeah?
Yeah.
Oh, great, thanks. So good afternoon, everybody. Thanks so much for attending our workshop. So today, yes, I'm going to be talking about extended reality and some of the interesting industrial use cases and benefits. So for the past 10 years, I've been working in the Nimbus Research Center, as Faizan said, providing a wide variety of user experience research and design services to SMEs and our industry partners. So my own interests predominantly are obviously in UX research, but also in natural user interaction technologies such as gesture control would be, and tangible computing combined with Internet of Things technologies. So I suppose over the past few years, there's been a significant demand from our industry partners around exploring the opportunities for both virtual reality, augmented reality, and mixed reality. So I would have kind of done a lot of theoretical or state-of-the-art research across kind of a variety of projects ranging from virtual hairstyling to augmented reality for finding kind of assets on oil and utility, to also in the manufacturing domain. So that kind of led us to take a step further and get kind of funding from Enterprise Ireland to develop our Extended Reality Innovation Lab, which I'll speak about further or later in the presentation. So firstly, I'm just going to give a quick overview of the talk. I'm going to talk about what is XR or extended reality. I suppose everybody's hearing about virtual reality, augmented reality, and now mixed reality. So, the lines can get a bit blurred. So I'll attempt to try to define it. Then I'm going to just talk about what these immersive technologies can do. I'm just going to point out maybe 5 things. And hopefully later, Mike might dig a bit deeper and give kind of some industry applications of where XR or AR, mixed reality, virtually has been used. Then at the end, maybe I'll just talk about kind of the Nimbus, our extended reality innovation lab, our new lab, and look at the kind of the industry use cases, the applications, and how we're using it, and maybe just talk about some of the insights. Then I hope at the end that you'll have some questions for us. If not, Faizan might throw a few questions at us, and where we can discuss maybe you know, the trends, what are the challenges, but most importantly, your own ideas or kind of insights. So I'm sure many of you have heard of, as I said already, VR, AR, mixed reality as now, but what is extended reality? So extended reality, I suppose, is a kind of a catch-all or an umbrella term that describes virtual reality, augmented reality, and now mixed reality, but also describes what is yet to be created. So it also kind of describes the future of immersive technologies, so incorporating human machine technologies, tracking devices, etc., more wearables. So we're basically looking at blending, it's all about blending the kind of the real world with the kind of the virtual world, where it will become kind of indistinguishable to people, you know. So we're kind of driving ahead, trying to get that far. So what I'll try to do is basically, you know, just maybe make a distinguish between virtual reality, augmented reality, and then mixed reality as we go next. So in virtual reality, you know, users are fully immersed in a kind of a simulated digital world. You'd be familiar with the latest kind of VR headsets. There's the HTC Vive or the Oculus, for example. So the user is immersed in a kind of a full virtual 360 kind of experience where they can kind of explore fantasy worlds, walk on Mars. But even more recently, what's kind of interesting, these VR headsets could be combined with virtual reality 360 cameras. So for example, they could explore, you know, like a real-time factory floor, for example. So in gaming, you know, virtual could be very much, you know, virtual reality very associated with gaming, but it has major opportunities to be explored within manufacturing, healthcare. So there's more useful kind of purposes outside of just gaming. Then when we talk about augmented reality, you know, it's about combining, you know, digital information and compositing digital information onto the real world. So you can access AR experiences from kind of a wide taxonomy of devices, ranging from heads-up displays to the glasses. But what probably people are more familiar with is probably from their mobile devices, their tablets and smartphones. So some of the kind of the people be more familiar with probably with Pokemon Go, where you kind of collect digital characters, and so you can see the digital character in the viewfinder with the real feed from your camera, to you know, like silly kind of filtering kind of games or effects that you get on your mobile phones, such as Snapchat, where you put on like silly filters or hats. So like, you know, augmented and virtual reality, you know, in the mainstream kind of have these kind of consumer applications, but they have a far more impact when we talk about industrial applications later. So then mixed reality, it's really about where digital and real world objects can coexist and can interact with one another. So people are more familiar lately with, you know, the HoloLens, you know, so, you know, put on a HoloLens device where you can kind of see holographic objects in your view. So the difference with AR or MR is you can interact with holographic or digital information directly, so you can like scale, move about. So it's all about describing how digital objects or artifacts interact with your physical surroundings. So within spatial computing, with the likes of the HoloLens, for example, it can kind of scan your real world environment. It can understand the physics or the characteristics. So it basically has a cloud point of your physical environment. Therefore, where the physical and the digital can kind of interact with each other, for example. So we might show kind of examples of that in a while. Yeah. So yeah, we've been kind of working towards developing a lot of you know, kind of serious games in our lab. So we had some of our interns working with us the year, so creating you know, games within like manufacturing. So some basic kind of games would have been kind of sorting in a warehouse distribution center. So we might like get around to playing maybe some videos later. So I just want to get to, Mike can cover these kind of areas later. So what can extended reality do? So like XR is going to revolutionize industries and enterprises. The possibilities are endless and far ranging, so it's only kind of restricted by your own imagination. So therefore, I'm just going to talk about maybe 5 things and benefits and use cases. These are learn and train better, experience the otherwise impossible, deeper insights when you need it, and instant expertise when you need it to mobility and interaction. So, in terms of industry, in terms of like manufacturing, from the factory floor to the sales floor, there's a huge demand to upskill and provision the workforce with new knowledge. However, this is very challenging at the moment. There's a huge kind of skills gap. There's, I think it was in 2019, there was like 500,000 manufacturing jobs that are unfilled. So there's a rapid like retiring workforce as well. So there's that knowledge is probably not being transferred. So there's immediate kind of emphasis to transfer that knowledge. At the same time, there's a huge demand for increased automation, as factories and manufacturing plants are becoming IoT enabled. At the same time, we're trying to keep up to upskill ourselves in parallel. And right now, even in the era of like the pandemic, teams are becoming more distributed, no access to these facilities. So what are the benefits of extended realities, these immersive technologies over traditional, I suppose, instructor-led or traditional kind of forms of e-learnings, such as in the classroom or even digital? So the major factors really is saves time. So with, like, for example, with HoloLens, for example, you can get on-the-job training when you need it. You can basically scan a piece of machinery and basically, get that content when you need it, like a video or a training video. So there's it's basically expediting, task completion rates of how you get that knowledge. It's cost effective. Companies spend significant amount of, money on, travel, resources, where like it's not really affordable to replicate scenarios where equipment could be damaged also. And also the big one really is, machinery downtime. When you got trainees, you want to be having downtime on workstations. So you want to basically mitigate, downtime and damage risk, reducing errors. Health and safety is a big one, that we'll get to in a while. There's obviously, if you're moving a trainee into a manufacturing floor or onto the floor, there's significant maybe health and safety risk. So you want them to kind of experience or a simulated training experience before they make that transition. Also the cost of translation for content, if you have an instructor that has to translate content. So like digital content can, provision translation services. So it's basically XR allows you to kind of retain knowledge, you can train and upskill faster. So Mike might just get to some of those points in a while. Here's just an example of kind of a virtual reality simulation kind of game that my colleagues would have created. So here we're using the HTC Vive, so with some finger tracking capability. Some basic games there, that when we first got the access to the technology, we're upskilling ourselves. So we started creating kind of a variety of just basic kind of simulation training scenarios and games. So here's just a basic sorting game as an example. So I'm just going to talk about experience the otherwise impossible. So, extended reality makes it possible to experience the otherwise impossible. As I talked about earlier, like walking on Mars, to more recently exploring, manufacturing plants remotely. So there's many situations where it's just impossible or just dangerous to visit. Like for example, it wouldn't be really, safe to, undertake fire training for new trainees. So maybe like a simulation kind of environment would be kind of a more kind of accessible or more safer environment to do so in the first instance. Or just seeing things that are not there, for example, would be, like water utility service engineers going out on site and being able to say underground kind of piping. So the benefits are basically being able to experience things just do not exist yet. So factory plants that are being built, so you can explore them virtually, so you can kind of get an idea. So the benefits are enormous, like accessing these kind of experience anytime, anywhere. It's safe. You know, you can practice explore before being, in a kind of a situation where there might be risk or danger. You can reserve your physical assets, mitigating against any damage, and obviously the cost effectiveness of it all. So I might have some examples, but I'm just keeping track of time as well. So here's a nice example from a company based in Australia who provide fire training solutions, virtual reality solutions. Here they have a nice extended reality example, which I'm just going to play a snippet of.
All firefighters face the challenge of feeling prepared, confident, and ready to fight the next fire. It is difficult for training organisations to safely recreate the conditions of a real fire for training firefighters. There's now a new, safe way to prepare firefighters for the fireground, Flame Trainer, a world-first firefighter simulator that uses virtual reality and haptic technology. Flame Trainer immerses firefighters in a real fire scenario where they can feel heat and hose balls, along with realistic sound and vision. You can set up Flame Trainer in around 10 minutes. It comes in 2 suitcases with backpack, self-contained breathing apparatus, hose reel and branch, virtual reality subsystem with computer and interfaces, heat suit, and scenario software. The equipment fully integrates with industry-standard firefighter personal protective equipment, realistically simulating all of the firefighter's senses. To enhance training outcomes, Flame Trainer tracks user performance. The instructor can monitor the firefighter's air usage and respiration on the system's tablet and provide live feedback on firefighting techniques. Flame Trainer has over 30 real fire scenarios that mimic real fire behavior, including its movement, smoke, flashovers, and explosions. Flame can develop new firefighting scenarios to meet specialist training needs. You can now train anywhere at any time. Flame Trainer takes the training to your firefighters and can be shipped easily if you have instructors in multiple locations. Flame Systems is based in Geelong, Australia, and was born from 10 years hardware and software development research at Deakin University.
Great, so that's a really good example that I like, that it shows kind of integration of other technologies, so that kind of a tracking device on the hose, where they'll also be able to provide like tangible feedback to the wearer. So that's a good example of XR. Here's just another good one with, I'll play this briefly, with the HoloLens, which is provided to kind of field workers working on underground utilities. So, seeing kind of utilities what would be difficult to see otherwise underground. So there's kind of major benefit there. Obviously, that could be complemented with integrated sensing feedback or sensors or data visualization provided back from real-time data. So there's just 2 examples of where it's either kind of too dangerous or just getting access to kind of information that's would be otherwise possible. So next, I'm just going to talk about, getting deeper insights when needed. So what I find is like one of the most interesting kind of use cases for, extended reality is when it's combined with industrial IoT. So, on the factory floor, you could see like assets that are integrated with, sensing, actuation, networking kind of capabilities. So when workers provision with like a hologram or HoloLens headset, they can basically get real-time feedback in relation to how that asset's performing. So a digital twin is basically a virtual representation of an asset, a building, or an environment that not only represents the geometry, but the interactions, the processes, the systems, so that allow it to function. So the benefit for a worker is like in situ, they can get kind of that real-time information in a very kind of meaningful contextual way to make kind of immediate decision makings. But for remote workers, they can control kind of assets on the factory floor as well remotely. I'm just gonna maybe just talk about instant. I suppose one of the most kind of accessible or people's first experiences of mixed reality is with the HoloLens. So it comes with remote assist, so workers can get remote assistance when needed. you know, so it's equipped with the real field of view to get real-time feedback from a remote, a remote technician can guide them and provide them with the structure when needed. So I'm just going to move ahead. Also, the big kind of benefits around extended reality related to mobility and interaction. So it's probably the most immediate kind of benefit is having hands-free, you know, capability. So being able, you know, like a worker or a technician, you know, holding paper-based kind of content or mobile devices kind of makes it very difficult for them to work on whether it's fixing machinery or equipment, for example. So I'm just going to play a clip here that kind of brings this all together from Colin J. Paris's PhD VP of software research, who describes kind of like, gives a kind of a good scenario where describes gesture interaction with a digital twin in a kind of IoT scenario. I'm just going to skip.
Okay. Twin, show me where the where is. Twin, show me the length of the where and plot a baseline for me so I can see if we did no mitigation, what that would be. Okay, Twin, close the steam turbine. This thing is still floating around. What you saw there was an experience with one of 551,000 digital twins that we have currently running. This one can communicate with us in a richness of voice and vision that is usually unbelievable, but quite real. But all of them deliver value.
So I'm just conscious of time, but I just thought that was a really good example that is like combining the digital twin in a kind of a mixed reality experience that shows the kind of really benefits of those modalities of interaction, voice and gesture when combined together. So I think that was so I'm just gonna, with the remaining time there, the last few minutes, I just want to talk about our extended reality innovation lab in Nimbus. So our extended reality innovation lab was funded by Enterprise Ireland through their capital call grant. So the Extended Reality Lab combines all of these technologies, so virtual reality, augmented reality, and mixed reality, where we're kind of really focused on kind of Industry 4 applications, such as the similar kind of applications that you just saw there. So our Extended Reality Lab, again, is a kind of a safely monitored environment for our researchers, our industry partners, where they can explore their ideas, their designs, develop and test the latest advancements in extended reality technologies. So just in terms of the layout there that you see, we've built, it's a trusting system rig where we're able to kind of attach a variety of kind of like sensing technologies, cameras, etc. And we have green screen capabilities as well. So we have two kind of stations. We have a VR station and a station where we kind of record and broadcast as well and stream some of the applications. So the applications we are focused on are in the educational domain, are kind of immersive, self-guided, interactive, you know, for visual learning, you know, simulation training that I talked about earlier, assistive AR in relation to inspection, repair, maintenance on the factory floor, safety monitoring, obviously digital twinning that I talked about earlier. So we're really looking around kind of digital transformation of paper-based manual processes. So that kind of instant support kind of scenario that you saw there, that I'm able to kind of get instant support, whether it's from a remote technician or else being able to scan an object and download an SOP or any kind of training material in the moment that I need. So there's significant benefits, as we talked about already, around the health and safety, you know, hands-free operation tracking, richer real-time data visualization. So there's all these applications we're really kind of focused upon in Nimbus. That's just, if you want to check out our website and see the kind of setup, you can do that. So basically, that's our kind of our setup in our extended reality innovation lab. So we've basically invested in a wide variety of equipment in our lab. These range from the latest VR headsets, HTC Vive Pros, Cosmos, etc., and the Oculus Quest. We've also invested in HoloLens 2 mixed reality headsets, 360 VR cameras, which work really well when combined with the VR headsets. And Arctec 3D scanners, so we can really, you know, reverse engineer, scan, you know, equipment really quickly and create digital assets really quick and bring them into kind of the game engine, you know, to kind of create kind of virtual experiences. And also motion capture suits, so wearables as well, and hand tracking devices. So we've basically got a wealth of different kind of technologies that we're going to leverage in our lab. Our lab is used, has a multi-purpose kind of usage to it. Obviously, we're going to use it for learning and training, research, exploration, but it's also kind of a design space, you know, for immersive visualization, review, 3D modeling, scanning. So we're using the space for a lot of things. So basically we have AV recording kind of studio. So we're hoping to like record trials and testing, for example. And also whether it comes to kind of like webinars or workshops like today, we could actually, you know, broadcast from the actual studio. Obviously it's been very difficult during the pandemic to do that, but we got the lab built only over the last few months. So it's still kind of in its infancy. In a way, so we're just combining our UX lab with our extended reality lab as well. So our designers can create, you know, rapid paper-based prototypes, but they can be, those concepts then could be handed over to our VR or XR developer team who can implement them really rapidly. So you can, we're creating that kind of workflow. Some of the projects that we are working on are in kind of biopharma space and working with a pharmaceutical company on in relation to digital transformation of streamlining their existing paper-based kind of process around quality control. So being able to download this kind of, or digitize these documentation, make it accessible, improving the kind of the user interaction of completing tasks really quickly. And also then in the automation kind of space, we are working, providing UX consultancy services, maybe that Mike will talk to in a while, in relation to kind of AR assistance in kind of manufacturing, for example. So just a quick insight before I wrap up there, I'm conscious of time. This area is going to significantly grow, you know, it's 8 times valuation in the next, you know, 4 years, 209 by 2022. There are a lot of challenges. It would be very difficult to get through all of those today, but to make it more mainstream, I suppose, cost, there's a lot of technical design challenges. I think the kind of design and ethical kind of challenges are the big ones for me, so that they're not like wearing, you know, how Google Glass kind of failed in relation to kind of privacy issues, social issues, but also the big ones around protecting your personal data. So we might kind of welcome a few questions around the challenges later. That's it for me. Thank you. I found it kind of difficult to get through a lot of that content in such a short amount of time, but we will welcome your questions at the end. So I'll hand it over to Mike now. Thanks, Faizan.
Thank you, Kevin.
Thanks, Kevin, and nice presentation. I can appreciate a lot of effort gone into it and very visual. So thanks for that. I think I'm maybe less visual and a few more words inside in mind. So do please bear with me. So I'll try and share my screen here and the presentation that I put together. Just go here. One. Okay, my apologies here now, guys, but seems if Zoom was somehow blocking it. Yeah. Kevin, I'm not sure if you're in a position to maybe just bring it up on your side, just the slide deck from last night.
Yeah, I have it there, Mike.
Just system preferences here. I'm normally using Teams, and I think that there's a setting here that's just preventing me from.
Do you want me to actually run from my side, and then you can let me click through? Yeah,
that would be good. Just drop off video here. But just while we're doing that, thanks everybody again just for joining us. Slide deck here that you should see, just a little bit of background on myself. You see, originally from Cork in Ireland, currently based in Pennsylvania in the US. As the guys mentioned earlier, I'm the owner of Horizon Controls Group and the founder of the International Academy of Automation Engineering. I've been involved in the life sciences and automation industry since the mid-90s, and basically I have a very keen interest in the developing technologies. The International Academy of Automation is a not-for-profit education and credentialing entity, and we've got strong connections with industry and with universities on an international basis. We've developed primarily out of our Cork office education, automation, engineering content that has been shared as far away as Singapore, across Europe, and also to North America. So it's gathering a lot of momentum here, and it's very much driven by the adoption of the Industry 4.0 technologies and the digital transformation. So on the next slide here, just kind of focus here and thinking about the content today. I believe that the mixed reality is the future for the mobile worker and industry, and that's kind of a focus of a couple of slides that I've put here. I'm basically bringing some experiences in the life sciences industry just to support this. What you'll see here is a representation of the newer design around pharmaceutical manufacturing, very much modular in orientation, miniature insofar as there's a big push to reduce the footprint of the manufacturing facilities. They're flexible for new product introductions. Their continuous processing is a big push in the industry at the moment, as opposed to the traditional batch manufacturing. And they're using disposable techniques. Not quite sure I agree that they're disposable technologies, but they are essentially replacing stainless steel equipment, vessels and the likes with disposable tubing, plastic tubing, and large plastic bags that would actually hold the contents and instead of the vessels themselves. And the idea there is to reduce cycle time on the batches by not having to clean and sterilize the equipment between each use. And then lastly, portable. So it's very much portable equipment that will get moved around and utilized in a few different locations as needed. So on the outside with the blue, you'll see here that it's very data driven topics, right? So whether it's OEE or the analytics and control, it's, and again, the mentions of some of the technologies that Kevin had there around digital twinning, PAT, process analytical techniques, and a lot of this is all enabled by the underlying IIoT and smart sensors. So we could go to the next slide, Kevin. So why do I say it's the future? Again, you need only look at the investments from some of the large companies and universities, just like what Kevin showed you, some great technology, great innovation going on with Nimbus, large companies, especially in the technology sector, that are pumping massive amounts of money into developing solutions just to get the competitive edge. You would have seen there from GE earlier and the digital twin. Again, that's not a cheap endeavor for any company, and so to be able to support that in the long term takes a lot of financial resources. One of the items to note there in under the investments, the recent past, Rockwell Automation invested over $1 billion into PTC. It wasn't an acquisition, it was more of an investment and a partnership to collaborate on where automation engineering and technologies like AR and VR and CAD are combining for use and at enterprise level. And so that's a very successful partnership that's going on at the moment. And below, as Kevin mentioned, there is a focus on addressing the skills gap and the generation of manufacturing workers who are retiring, and trying to capture their knowledge and pass it on to the next generation. So the next slide here speaks to trends that are driving the future. Again, at the core is data, trying to make better decisions based off of data that is available to the manufacturing process. And that data primarily is generated from smart sensors. And again, the topic around today's overall event is on IIoT, and that's coming from the smart sensors and then the enabling computing power that's developing all the time. So machine learning, advanced process control, edge devices, and pushing the application and data analysis out to edge devices. So, distributed computing power is very much the forward thinking process. Additive manufacturing and digital twins here again, 3D printing, virtual testing and commissioning, anything to speed up the process and to gain an advantage. So historically, to commission a piece of equipment or plant, you had to wait for it to be fabricated and installed and connected up to utilities and electrical systems. Now a lot of this work can be done virtually, and it's getting great advantages to businesses. They've got the connected worker, the connected machines, connected operations, connected enterprise, and the connected supply chain. So quite a line of connectivity there, and it's all again driven by the data and the availability of data. Another trend around the virtual and augmented environments, focusing around low code or no code solutions, software as a service deployment, and cloud computing. Again, just massive increases in the last number of years around the computing power, which is enabling a lot of what we're talking about here today and what Kevin has shown very visually in the last section. Finally, on this slide, the cybersecurity is another trend and a very hot topic. Some very large and noteworthy cyber attack events recently, which is putting a lot of focus on the adoption of some of these technologies into the enterprise. And so, coupled with any ARVR solution, you've got to be thinking around the cybersecurity aspect of deployment at scale in some of the enterprise areas. So we'll just go on to the next slide there, Kevin. So the approach we're taking here is just to kind of focus in on some of Kevin's earlier topics and just some of my experiences of where these are being used in industry. Again, we'll just take it down through each of the steps there. So on the next one slide, Kevin, we have just some local applications there from a CIT perspective. The Pfizer implemented an AR-guided workflow at their facility in Ringaskiddy in Cork. This was presented at a recent industry event, and the feedback was very positive. Pfizer took initially a relatively simple, for want of a better term, approach, whereby they got an application, they got the technology, they proved out the concept, and from a business perspective, the value to the business. And then they took that application and they brought it to a few different facilities. So it was just small steps for them so that there was an interest and an adoption by people and that they weren't overwhelmed by the technology. So I thought that was quite a good approach. And then that they're just building the familiarity at the site, and then they will scale out at that site as the technology becomes more widely adapted at the site. The next point here is just from our own company perspective, we're heavily involved in and around this technology area with augmented reality and virtual reality, and layering on top of that then some pretty advanced computing solutions. So we have a current client that we are implementing a voice activated augmented reality enabled guided workflow, and it's basically a manual operation where the client was concerned over safety concerns that operators were not correctly following the paper-based standard operating procedure, and felt that if we could augment the environment for them, that it should prove valuable and less critical from a safety perspective. So that's another very good application of these. Kevin, I'm not sure if this link here under NIBRT would work for you on that. Might just bring you out to a different, it's just a hyperlink out to a YouTube video.
Oh, it's on the text.
Yes. Yeah. So it may just try to get out to your, but basically NIBRT research facility and education facility, government backed in Dublin, and they have recently produced some virtual training specifically for the cell culture area in a biotech manufacturing facility. So it's a short little video on that, but it's not embedded there, Kevin. It's linked out to YouTube. So I'm not sure if that hyperlink works.
Yeah, sorry, Mike, it's still loading.
Okay. There's just a preview tab on that there, Kevin, then if it comes through. So in NIBRT, again, just to kind of put it into perspective, NIBRT recently issued a link out to people in their email groups to access their content, to have a review of it and provide some feedback. It's early days in the adoption of this type of technology, and therefore they wanted to see how they could progress. So Kevin, I think you'd shown some of the virtual interactions there earlier, so just kind of a little bit conscious of time here on my side as well. So let's maybe just jump to the next slide, and we'll see. There are videos here, so I'm happy to share them with anybody, similar to what you had shown earlier, Kevin, around the experience of the otherwise impossible. What was very interesting here, especially through COVID situations, construction workers using augmented reality on the building site. So much like what you showed, Kevin, with the utilities on the roadways and the underground piping, and the use of 3D rendering from a building information model, and you overlay that 3D data into a construction site, and you can see where ductwork or cable trays should physically go, and then you can determine whether or not there'd be any conflicts, clash detection, whereby it could a cable tray could be on the path of a newly erected beam or footing, or just basically causing a clash of two physical components, and you can detect that before it goes in and maybe save some time on rework. It speeds up the installation and afterwards the commissioning, because again, you're overlaying from the digital environment onto the physical, and you can ensure that things are correctly installed. Kevin touched on a similar feature here, but we are seeing that 3D camera footage. So you could take on a construction site, rather than having people, too many, say, management people showing up to walk down the construction site, you could use a 3D camera to gather footage so that you could have a virtual walkthrough. And you could do this pretty quickly and on a daily basis, and publish it in the cloud, and have people in remote locations look at the content, and again, saving on travel, saving on people having to come on site when the pandemic situation was proving problematic. So next slide, Kevin. Some on the topic of deeper insights, on-demand access to real-time and historical data. Again, just like Kevin's video showed around the digital twin, augmented reality is providing a timely overlay of critical machine data. So again, on-demand, gesture-driven, predominantly driving towards voice-driven as well for truly hands-free interaction with the environment. Again, the creation of data lakes in the pharmaceutical industry is quite prevalent at the moment, and that's to gather large amounts of data, and then the companies are running machine learning algorithms and analyzing the data coming from the smart sensors, and it's helping them make big savings and unearth even products that and solutions that they were unaware of just because they didn't have the physical ability to mine the data at the level needed just from a human perspective. Kevin touched on the digital twin. We as a company are in a lead role on an FDA project here in the US involving the assessment of digital twins, the improvements of capacity and mobilization in pharmaceutical manufacturing. So basically we're conducting research across numerous pharmaceutical manufacturing companies. We're developing a playbook around the implementation of digital twins for the manufacturing industry. And we will be installing digital twins on a couple of facilities. And the overall intent is to stress test the digital twins to see how it might better aid capacity of the equipment in the event of another national emergency. So it's ongoing work, and it should prove very interesting, and it's forward thinking from the perspective of the FDA to plan for the future. So next slide, Kevin. Instant expertise, I think Kevin covered a number of these points here. I won't dwell on them, but again, just zoning in on the cost savings. You can hire less expensive resources and use the technology to augment skills, and that's particularly a benefit where you don't have access to the skilled workforce for certain critical tasks. It also reduces the travel need, and you don't need to get the subject matter expert on site. And one recent benefit that we saw from our company perspective, we were involved in a project where we were making some modifications to a boiler plant at a pharmaceutical client, and the commissioning was conducted remotely, believe it or not. Our subject matter expert was based in one state, and then there was local electrical engineers at the boiler who were actually able to test remotely the work that we had designed, and that was implemented by an electrical contractor. And so we were able to sign off remotely. And again, because of restrictions of having people on site and also cutting down on travel interstate, we were able to conduct the work remotely. And again, the use of headsets and the likes of Teams and other virtual environments aid that significantly. And the next slide there, Kevin. So just the mobility and interaction, conversational AI using two-way voice interaction to assist. This became quite interesting to me at a recent, maybe about 12 months ago at a conference I attended, and somebody from a very large oil and gas company mentioned that digitizing the SOPs, the standard operating procedures, wasn't enough for them because they had significant literacy challenges with their manufacturing personnel. And it was made me just think about that, and the fact that voice then can actually assist in overcoming that. I thought it was good. Voice and audio to assist visually impaired and also as an extra modality for VR training. So I think Kevin touched on some of these here earlier. And moving forward, the spatial computing applications. And there's just a good example here on the conveyor. And we might, again, saving on time, Kevin, unless it loads quickly. But it's basically a conveyor system whereby there's a spatial toolbox, and you can interact with virtual on-off switches, and easily just by swiping the finger, you can.
It's an experimentation platform.
Yeah, maybe just on a different screen on sharing there, Kevin. But it's basically just showing how you know, with an overlay of AR, that the one can interact with the environment and quickly make operational changes to machine processes.
Mike, we are only left with 10 minutes now.
Yeah.
Maybe you
So
can take some
that's-
questions from the participants. Yeah.
Certainly, the last slide there was just closing out there, and so again, just
Oh, yeah.
to reiterate
Yeah.
the point that it was the mobile worker and the augmented reality or virtual reality is the way of the future. I think it's inevitable. It's just you know, all about the adoption of from here moving forward, and the advancing of the technology. So thanks for your attention. Hopefully that was informative. Feel free to ask any questions or reach out to me via email.
Now our chat was disabled due to, I don't know why. I'm still figuring out. What we can do is I have allowed you participants to unmute yourself. So if you have any questions, you know, you can directly ask Mike or Kevin. Kian, Francis, Joshua, Nitin, Ronan, and Stephen. Like, if any one of you has any question for the speakers, just feel free to ask them.
Hi everyone, I'll come in if you don't mind.
No worries.
Yeah. Good.
So guys, thanks a million for the talk. Really insightful with some really cool examples as well. I won't go into my own background too much, but I just started a PhD a couple of months ago at MTU, and we're looking at the use of mixed reality headsets, so your HoloLens, and how it can be used by people working in remote or extreme environments. So people, whether it's people looking to conduct medical help or deliver medical care in Antarctica or on the moon or remote places like that. So I was just wondering if you had any examples, because I'm struggling to find any at the moment of any augmented reality applications or examples that are actually using AR headsets or MR headsets in the delivery of either assistance to people or conducting procedures, because a lot of the examples in literature and that companies are using this whole idea of remote help. Basically, are you aware of any scenarios where people are using MR to basically replace that remote help where that help isn't available?
Yeah, I'm happy to jump in there, Kevin. Thanks, Kian, for the question. I have some applications and experience of that. A good friend of mine is founder of a company out on the west coast of the US. I want to say it's relatively newly formed in the last 12 months, but he's steeped in augmented reality headset development, and he has a company that's specifically focused on using headsets for first responders, amongst other things, and very much focused on the healthcare side of things. So for doctors, hospitals, again, trauma situations where the first responder in the field can actually connect with the hospital and show some, you know, vital statistics of the injured party and render even better assistance remotely while they're transporting the individual. So I could try to pull up here just if I can get the correct site, but feel free to shoot me a note afterwards there, or I can get it to Kevin. But it's Hippo, I know, is the name of the company. I'll just try and dig out the website there. But Kevin, if you have any thoughts there, I'll just try and get a link.
Sure. Mike, what I'd say to Keen is if you could contact me after this via my email, we'd be happy to number one, just look at maybe the opportunities of accessing or having availability to the technologies, you know, to you. But certainly we have worked with kind of a range of clients, but as I said at the beginning of the talk, it's been very much kind of state of the art, kind of theoretical research, where we're trying to move that forward now to kind of implementable kind of demonstrators. But certainly happy to chat about your research after this.
Cheers, thanks a million. No, I'm only 4 months in, so I'm very much just in the assessment of my state of the art. We haven't nailed down the hypothesis yet, so I'm sure I'll be in touch.
Very good.
Sure.
And do we have more questions from the participants?
Hi, my name is Ronan. Thanks for the talk, guys. It was really insightful. I'm actually a fourth year media student, and I'm currently looking at basically developing just a concept on for essentially my final year project on making a, you know, like a director's viewfinder, trying to make that digital. So I'm trying to combine traditional filmmaking techniques with you know, modern kind of pre-visualization methods. And I'm just kind of wondering, because I was looking into augmented reality a lot, but I was wondering, you know, there was I actually worked with, I'm in the same course as Peter Hayes,
Okay.
who had worked with that already. And he was saying he was using the HoloLens and all that, which was incredible, I thought. But I was just looking at it from the point of view of essentially trying to look at it where if someone had, you know, something similar to the HoloLens or something like that, to be able to see, you know, a shot or how you want to set up a scene exactly through someone else's eyes. I was just wondering if there's any, you know, examples or technology or anything like that that you'd be able to recommend or
Yeah,
advise
there's
on.
what's known as XR studios. What they do in the green screen environment, they have kind of IR markers. They kind of construct as a point of reference. So in your gaming environment, you could basically kind of map the gaming environment to the actual physical. Another kind of interesting thing is in relation to the 360 VR cameras. You know, like bringing in 360 into a VR environment and just pairing that with, I know in your case, you're talking about the kind of the HoloLens where you can composite like a frame of reference for filmmaking. Certainly you can do that. So what I have seen with the Insta360, like say camera has been paired with VR cameras, there's huge opportunity for kind of live, interactive, immersive kind of video. But I think you do present an interesting use case where the HoloLens could be used, you know, like within a film production set. But I think you should check out some kind of XR studios maybe, where I think they kind of present something that maybe could benefit your research. I can share those with you.
Yeah, that'd be great. Thanks for that. Because like another one that I was looking at was, you know, if you're setting up a scene or something and you want people to see exactly what you want to show them, would be the use of bringing in like, you know, through the use of augmented reality, say in a certain location or something, showing, you know, a certain type of props or actors. And even you were saying there, Kevin, about using the motion capture suits, about how, you know, you'd be able to create like something to be able to use with that. So that was great actually to be able to look into something like that as well.
Yeah, certainly. The use cases are only kind of limited by your own imagination, but what you're talking about is definitely in the realms of extended reality.
Perfect.
So like Garvin and Peter, who were on the course which you would have worked on kind of extended reality experiences where we would have kind of combined kind of physical assets, like putting trackers, motion trackers on objects. So they could be like a motion tracker being, or like a Vive tracker being put on a welding machine or a handheld tool, where, you know, the real person is then in the kind of the green screen or the physical environment, where you can kind of blend the virtual reality or the game engine. And then combining that with, you know, the interaction that it has to offer with the HoloLens, for example, like say spatial computing, being able to scan physical environment, you know, so you're interacting with physical and digital at the same time. So yeah, like again, with Cian and yourselves, what our ambitions are to kind of have more outreach with MTU and students, see kind of what ideas they have, and kind of like maybe collaborate with us in Nimbus and see kind of like how you can kind of just develop them further, you know.
Yeah, that's perfect. Thanks so much.
Thanks, Ron, for your answer. I think we're out of time. That brings to the end of this lovely talk. To conclude, I would like to thank Mike and Kevin and all our contributors. You can check out other workshops taking place on the event website beyondiot.ie. And just to remind you that you can also visit the main stage and research stage at any point. Thank you for attending this workshop at Beyond IoT.
Thanks a million.
Thanks, everyone. Thank you.